Welcome friends, welcome you all in my channel Chemistry and Mystery of Molecules and Online. So today I shall explain a name reaction, that is Wolff Rearrangement. Previously I have uploaded Arndt Eistert reaction. That reaction utilizes Wolff Rearrangement, and that time I didn't explain it in details, which I will do today. So let's start. So this Wolff Rearrangement is nothing but the rearrangement of this alpha-Diazoketone into ketene, a reactive intermediate and very useful because lots of material could be prepared from ketene, and this process could be carried out using light, heat or silver plus as a catalyst, means a transition metal catalyst. So among heat and light, silver, this amount heat it needs lots of energy, but for that from that problematic perspective, these light as well as these transition metal catalyst reactions are more easier and facile due to this conversion. Okay, so what happens actually? This process could be achieved in two ways. One is stepwise and another is concerted. Stepwise means this nitrogen could be eliminated first stage, which results in the formation of a carbene intermediate, and that carbene will undergo rearrangement to produce the alpha haloketone. So what happened? This carbene, this is resonance stabilized by this conjugation with the carbonyl group. So how does it look like? Actually it looks like CO minus double bond R. This, but still this is a 6 electron species. This is also a 6 electron species. So this is also, so it's reactive, and that's why actually what happened, this group migrates. So you can write this or this. If both process happen simultaneously, means the leaving of this group, it comes here and R migrates, then that is a concerted process to achieve the ketene and this. So whatever the process, it will result in the ketene. And actually what happens, if this is stepwise and we take a label carbon, means for example if we take this carbon as a label as a 13C, then what we have chances that we expect that this label will come here and ultimately this will produce that ketene, and ketene, so this R will migrate and it will produce C double bond O, means this carbon is this one. Okay, so this should be expected that this is the label. So after hydrolysis it will produce, this will be carboxylic acid, means another thing, here will be hydrogen. Okay, but actually this is not the fact. What happens, this label is scrambled means ultimately here is also label, here is the also label carbon. Why? Because these undergoes a further oxygen intermediate, it can undergo, because it's a 6 electron species, so electron deficient. Another thing, oxygen electron, so this oxygen can attack this center and it can produce, means instead of my rearrangement, before the rearrangement it may have another step. So that is R double prime oxygen. And another thing, keep it in mind, it is very reactive because stabilization is less because of double bond as well as 3 membered in first point. Second point is that here one lone pair of electron is involved in the ring. So here 2 electron, here 2 electrons, so 4 electron, and that's why this is anti-aromatic in nature. But so it is true that it is very much reactive thing, but it is possible, and this phenomena explains why this level is scrambled, because after this both, means if this side can open and prepare a O minus, and similarly this side open means this. So at these circumstances this R double prime can migrate, R prime can migrate. So there is a true chance. That's why this scrambling occurs. Okay. So we have discussed first point, that is the concentrator stepwise, second heat, and product is ketene, and finally the most important thing, that is the retention in configuration. What happens when whatever group migrates, this R prime or R double prime due to this, so ultimately there is a chance that there is a, we can expect that okay, retention of stereochemistry or change in stereochemistry or racemization possible, but what happens here is retention in stereochemistry. Why? Because the whole R group migrates. Okay, so in the, that is another important thing. So this Wolff rearrangement, what we have observed, produces a reactive intermediate ketene through in this pathway. This is the mechanistic. And what happened? Actually, this is the Wolff rearrangement produce the ketene, but ketene is a reactive intermediate. That's why it undergo further reaction in the medium. And what it produces? If we take water, then means weak nucleophile can attack this center because it's a highly electron deficient and activated, and it's a delta plus. So electron deficient, so attack here, water, ammonia, or we can say methanol, alcohol can attack, and finally it can produce carboxylic acid, amide or ester. And actually that is the Arndt Eistert reaction, that is a homologation. So in between this carboxyl group and this, one unit of CH2 is introduced, and that is coming from diazomethane. Okay, so this is the utilization of this ketene. So I will stop here. In next video I shall give some example about Wolff rearrangement as well as Arndt Eistert reaction. So if you like my teaching, please give a like and subscribe my channel Chemistry the Mystery of Molecule, and please press the bell icon to get the notification of every single video I upload, and finally share this video among your friends such that many people could be benefited from my info. So see you in my next video.